Welcome back to our YouTube channel. Today we are going to be doing example number 2 that says we should find the Laplace transform of f of t equals to t. Now by definition, the Laplace transform of a function is defined by, so this is the definition of the Laplace transform. To find the Laplace transform of any function, you firstly have to know that the result will be a function of s, and that will be the integral from 0 to infinity of e raised to the power of minus st times f of t dt. To find Laplace transform of t, we replace e to the power of minus st, and then we replace f of t with the value of f of t, which is t. So t dt. To evaluate this integral, we are going to use something called integration by parts to evaluate this integral. So to use integration by parts, we say let u equals to t and let dv equals to e raised to the power of minus st dt. We are going to differentiate this side. We are going to integrate this side. So the derivative of u is du, and the derivative of t is just dt. We are going to integrate this side. The integral of dv is just v, and the integral of e raised to the power of minus st dt is minus 1 over s e raised to the power of minus st. The integral of u dv is equal to uv minus the integral of v du. So we have the Laplace transform of t to be equals to, we have uv. What is u? U is t and this is v. So uv will be minus t over s e raised to the power of minus st evaluated from 0 to infinity minus the integral of v du. V du. This is v and this is du. So v is minus 1 over s e raised to the power of minus st, and du is dt. So once we evaluate this integral, the result will be the Laplace transform of t. So we can go right here and just rewrite minus t over s e raised to the power of minus st from 0 to infinity, and then negative times negative is positive. 1 over s is a constant. It comes at the back of the integral. 1 over s, the integral of e raised to minus st dt. To evaluate this, we take t for the upper bound, so it's minus infinity over s e raised to the minus s times infinity minus. So remember this negative times the negative will be positive. There is a negative inside the evaluation expression that's positive, and then you replace t with 0, minus 0, so it's just 0 all over s e raised to the minus s times 0. This is 0 to infinity, and then plus 1 over s. If you evaluate e raised to the power minus st dt, you have minus 1 over s e raised to the power minus st from 0 to infinity. S times infinity is infinitive. E raised to the power negative infinity is 0, so this goes to 0. 0 times the entire thing also goes to 0. We're at the level of this. So here, this will be negative 1 over s squared. And then e raised to the power of negative st from 0 to infinity. We're actually evaluating, so this negative 1 over s squared is out here. We're evaluating e raised to the power minus st from 0 to infinity, because that is the function of t. Great. So if we do this, it's e raised to the power of minus s times infinity minus e raised to the power of minus s times 0. The power of minus st from 0 to infinity, because that is the function of t. Great. So if we do this, it's e raised to the power of minus s times infinity minus e raised to the power of minus s times 0. So this will be equals to minus 1 over s squared onto s times infinitive is infinitive, so it's e raised to the power of negative infinitive minus s times 0 is 0, so it's e raised to the power of 0. So this will be minus 1 over s squared times e raised to the power of negative infinity is 0 minus e raised to the power of 0 is 1. So if we multiply this times this, we are going to have the Laplace transform of t to be equals to minus 1 over s squared times negative 1. If you multiply these, you have 1 over s squared. Therefore, ladies and gentlemen, the Laplace transform of f of t equal t is f of s, which is the Laplace transform of t, to be 1 over s squared. Thank you very much for watching and see you in our next video.